In this mini clip, we'll be solving rational equations. While we answer this question together, you will be solving a similar problem on your own using the same technique. We are asked to solve the following equation: 2 divided by x minus 5 plus 3x divided by x plus 1 equals 4, where x does not equal 5 or negative 1. This restriction on our x variable is just to ensure that our denominator is not equal to 0. The easiest way to solve this equation is to first set it equal to 0. It will become evident why this is so later on in the solution. To do this, we need to bring the 4 to the other side of the equation, and we do this by simply subtracting 4 on both sides of the equation. So on our left-hand side, we will have 2 divided by x minus 5 plus 3x divided by x plus 1. Now we need to subtract 4 on this side of our equation. And if we subtract 4 on the right-hand side of our equation, we will have 4 minus 4, which is 0. I would like you to try doing this step with the question you are given. Here's the answer you should have got. Because we're adding and subtracting fractions, we need to find a common denominator. In our case, the lowest common denominator would be to simply multiply x minus 5 by x plus 1. So our common denominator would be x minus 5. This needs to be in brackets because we want all of this multiplied by x plus 1. We now need to manipulate our fractions so that they will all have this denominator. So let's take a look at our first term. 2 divided by x minus 5. We already have x minus 5 in the denominator, but we need to multiply it by x plus 1 to get our common denominator. So we want to multiply x minus 5 by x plus 1. We can't, however, just multiply the bottom by x plus 1 because this will change our original equation. Our original equation just has x minus 5 in the denominator. If we were to multiply our numerator by x plus 1 as well, as so, then we wouldn't be changing our original equation, since x plus 1 divided by x plus 1 is equal to 1. Multiplying any number by 1 does not change the value of this number, so we will still have 2 divided by x minus 5, which is our original equation. So we need to do this with each term. Our second term is 3x divided by x plus 1. Now we need to multiply this denominator by only x minus 5. So I'm going to put this in brackets. We're going to multiply this by x minus 5. To ensure we don't change the original question, we also have to multiply the numerator by x minus 5. Our third term is minus 4. To write this as a fraction, we can put it over the number 1, since 4 divided by 1 is still 4. This denominator needs to be multiplied by both x minus 5 and x plus 1. And again, we need to multiply the numerator by this as well. We still have this equal to 0. Now if we look at each one of our fractions, we'll notice now that they have the same denominator, x minus 5 all times x plus 1. So we can rewrite this line so that we combine the numerator onto one line and it will all be over our common denominator. And this is what I did in this line. I simply rewrote the numerator onto one line and I put it all over our common denominator. I would now like you to try doing this step with the question you are given. This is the answer you should have got. Now coming back to our question, we can now simplify our numerator by expanding. So we'll notice that we can bring this 2 inside the bracket, and we will get 2x plus 2 plus, we have 3x times x, which will give us plus 3x squared. Positive 3x times negative 5 gives us minus 15x. Now here we have 3 things multiplied together. So I'm just going to leave this minus 4 out in front, and I'm first going to expand these 2 brackets here. So x times x will give us x squared. So I need brackets here because we're still multiplying by negative 4. So we will have x squared, x times positive 1 is plus x, negative 5 times x, negative 5x, and negative 5 times positive 1 is minus 5. This is still over our common denominator. Lastly, we have this is equal to 0. Now we can expand this negative 4 into the brackets. So we will leave what's out in front here. We have 2x plus 2 plus 3x squared minus 15x minus 4 times x squared is minus 4x squared minus 4 times x minus 4x minus 4 times negative 5x positive 20x, and negative 4 times negative 5 is positive 20. Again, it's going to be over the same common denominator. And we're still going to have this equal to 0. Now, our last step will be to collect our like terms in the numerator. So let's start off by looking at our x squared. We have 3x squared minus 4x squared, which will give us minus x squared. Next, let's look at our x's. 2x minus 15x will give us negative 13x, minus 4x is negative 17x, plus 20x is plus 3x. And lastly, let's just add our numbers. 2 plus 20 will give us plus 22. And this will be over the common denominator. And let's not forget that it still equals 0. I would now like you to try doing this step with the question you are given. This is what your answer should look like. Because I ran out of room, I'm just going to scroll down a bit to give myself some space. So this is where we ended off. From this step, it should become clear why we want our equation to equal 0. In order to have our fraction equal to 0, the numerator itself must be equal to 0. This is because if the numerator is equal to 0, then we will have 0 divided by some number, which will always equal 0. So essentially, to solve this equation, we only need to look at our numerator. Once it is equal to 0, our entire equation is equal to 0. So we don't need to consider this denominator. We just need to solve for negative x squared plus 3x plus 22 is equal to 0. We would normally factor at this point to solve for the different values of x that allow the left-hand side of this equation to equal 0. This trinomial, however, does not factor nicely. Since this trinomial is written in the form of ax squared plus bx plus c equal to 0, we can use our quadratic equation to solve for x. To refresh our memories, I'll write out the quadratic equation. Our quadratic equation is x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. From here, we need to substitute our values for a, b, and c to solve for x. So we will have that x is equal to our b value, looking at this equation here, is 3. We have negative b, so we will have negative 3 plus or minus. Now we're going to have the square root of b squared. Our b was 3, so I'm just going to put this in brackets. You don't need them though. 3 squared minus 4 times a. Our a is found in front of our x squared, which is negative 1. So 4 times negative 1 times c, which is positive 22. So I'm just going to write 22. And this is all over 2 times our a, which is negative 1. I would now like you to try doing this step with the question you are given. Here's the answer you should have got. So now we need to simplify what's underneath our square root as well as what's in our denominator. So we have that this equals negative 3 plus or minus the square root of 3 squared will give you 9. Negative 4 times negative 1 times positive 22 will give you positive 88. And in our denominator, 2 times negative 1 is negative 2. Now because we have a negative 3 here and we have a negative number in our denominator, these negatives will cancel out to become positive. So in our next line, we will have 3 plus or minus the square root. Now 9 plus 88 is 97. This is all over 2. So the last thing we need to do now is that we need to write out our 2 possible values for x. So I'm going to write a therefore statement. Therefore, we have that x can equal, the first case we're going to consider is when we add the square root 97. So I'm just going to divide this into 2 fractions. So we will have x is equal to 3 halves plus the square root of 97 over 2. Or the second case that we will have is 3 halves, and we will be subtracting the square root of 97 over 2. Now it's always better to leave our answers in exact form, otherwise we'd be introducing round-off errors. So this is our final solution. I would now like you to finish off the question you are given. And here should be your final answer.